Here we have an example of a rational expression. So this whole unit is called rational expressions. Rational expressions, the definition is just basically you have a polynomial divided by another polynomial. So this divided by that. That's all it is. And we are going to now state restrictions for this. Before we can state restrictions, we need to factor the denominator. Otherwise, we can't easily figure out and make those two mini equations. For this example, how do I factor x squared plus 3x minus 18? Well, go back to your grade 10 factoring skills. M plus n equals 3. M minus n, sorry, not m minus n, what am I doing? M times n equals negative 18. So two numbers add up to 3, and the same two numbers are multiplied to negative 18. And let's see, what can those two numbers be? I have a feeling it's going to be 6 and negative 3. And 6 plus negative 3 is 3, and 6 times negative 3 is negative 18. So this is going to easily simplify to x plus 6 and x minus 3. So remember, this is factoring from grade 10. Hopefully you guys got a review factoring skills. Once you do this, we have factored the denominator. We can now state restrictions. And it's very clear that x cannot equal negative 6 from this first factor, and x cannot equal positive 3 from this second factor there. And something about simplifying rational expressions. You'll notice that the top and bottom have a common factor, a common bracket. They're exactly the same. So we can actually just cancel this out. Just like when you're multiplying a fraction, and you have, say, 2 times 3 over 2 times, I don't know, 7. The 2's will cancel out, and the answer just becomes 3 over 7. Just like that, common factors canceling out, common factors canceling out. So what does that mean our equation or our relation becomes? It simplifies to 1 over x plus 6. But what about the restrictions now? Because I only have one bracket in the denominator when I've finally simplified everything and I've, got my final answer. Does the restriction only become negative 6? And the answer is no. This is important. You need to do restrictions in the beginning or anytime something new is in the denominator, because you cannot divide by 0 at any point, at any step. Just because x minus 3 is not in the denominator anymore doesn't change the fact that it was in the denominator at one point. And by definition, even for a second, if it's in the denominator, you cannot divide by 0 at any point. So that's the rule. So even if you simplified it and it's not in the denominator anymore, remember to do or state your restrictions at an earlier step rather than the final step. Otherwise, you will be missing out on some restrictions. So the final answer is x cannot equal negative 6 and positive 3. And this is our final relation. So yeah, there you go. That's the notes. You can take a look at that. So same thing here. Just going to quickly show this to you. The same thing where the first step is to factor both top and bottom. So you always factor both top and bottom. The reason why you factor both top and bottom is to see if there's any common factors that can be eliminated. So in this example, 7, the top becomes x plus 7, x plus 3. The bottom is obviously x plus 3. And you can clearly see that the x plus 3's cancel out. And we just have x plus 7. That is the answer. That's the final answer. And normally, x plus 7, there are no restrictions because there's nothing to divide by. But remember, in the initial step, you were dividing at one point. So there is a restriction. X cannot equal negative 3. At this point, I'm going to mention something. Something that you will learn in your notes or the video if you watch the video. Graphically speaking, x plus 7 is just a linear line, because it's just y equals mx plus b. So the slope is 1 and the y-intercept is 7. Grade 9 stuff. Y equals mx plus b is just a straight line that goes on to infinity. How is this different from this initial thing? Because there is a difference, because there's an x cannot equal -3. The only difference between this and this initial and final step is that there is a hole. What do I mean by hole? Well, because this canceled out. This is the definition of a hole. Whenever you have a common factor on the top and bottom and it cancels out. And that hole occurs at the restriction value. So -3. So if I have -3 here, that means this equation, or this line, looks like this, where there's a gap in the linear line. So this is an example of a discontinuous function or non-continuous, meaning I cannot draw this function without lifting up my pencil. Doesn't mean it's not a function. It still is a function. Remember, vertical line test for every no repeating x values for different y values and whatnot. So still a function, but it's just a non-continuous or discontinuous function. And there's a hole in the graph at exactly x equals -3. So that's it. So graphically, this is what it looks like. Please watch the videos for more in-depth explanations. I don't have as much time. Obviously, this is like a 2 or 3 day lesson, and I only have an hour. So, yeah. Here we have x squared minus 9 over, the bottom quadratic. Once again, factoring, you got to know how to factor. This unit requires you to be able to factor. Remember your factoring skills from grade 10. But this is the difference of squares. A squared minus b squared equals a minus b times a plus b. So x squared minus 9 factors into these two brackets, x minus 3x plus 3. And the bottom is, once again, two values that add up to 7. Same two values that multiply to 12, 4 and 3, x plus 4, x plus 3. And as you can see, the common factors cancel out, and we are left with x minus 3 over x plus 4 with two restrictions. X cannot equal -4 from this factor here, and x cannot equal -3 from this value here. That's the answer. So that is essentially simplifying rational expressions and stating restrictions. Now I'm going to skip over multiplying expressions. Those are easy. Okay, maybe I shouldn't. I'll do one example. I'll do the hardest example. All right. Multiplying and dividing rational expressions are essentially the same thing, because if you remember your multiplication and division rules for